Okay, so we're doing part two of the 173 assignment. Part two wants us to find the center of rotation of these two shapes that have been rotated. Okay, it also wants us to find the rotation angle. And in addition to that, it wants us to write the rotation function. So three things. Okay, it's not too bad. All right, so in order to find the center of rotation of these two shapes, the general strategy is to connect two corresponding points and to find the perpendicular bisector to the line segment connecting those points. And if we do that for two sets of two corresponding points, we will find the center of rotation. And I'm going to walk you through that and show you what that looks like. Okay, so let's go ahead and pick two corresponding points here. And you could pick any. You could pick C and C prime, you could pick A and A prime, D and D prime, or B and B prime. Okay, and I'm going to pick C and C prime because those just look appealing to me. And I'm going to go ahead and make a line segment. And so boom, we get a line segment between two corresponding points, C and C prime. And now we want to find the perpendicular bisector to that line segment. Now, in order to do that, you're going to need the compass. Now, take your compass, and I'm going to make these marks in green, and make two arcs from either side. Okay, so we're going to set this compass up so that we can make a mark here. Draw a line segment. I mean, not a line segment, an arc. And then we're going to go to the other point, and we're going to keep our compass at the same distance, and we're going to draw an arc from that side. Okay, and so now that intersection of the arc is what we're interested in, and we want to do this on the other side as well. Okay, so I'm going to make my arc there. I'm going to move it to this point over here. And so, likewise, on this side, that intersection is what we're interested in. We want to connect those two intersections with a point. With a line. Okay, so it's going to look something like that, right? We have a line going through this intersection and this intersection, and this is the perpendicular bisector to this line segment C to C prime. Let's go ahead and make another line segment between two corresponding points. I'm going to pick D and D prime here. Okay, so same thing. We just connect the two corresponding points with a line segment. This one's going to be purple. And now we're going to draw the perpendicular bisector to this line segment. Okay, so we're going to get our compass. We're going to set it at one of the points D. And we're going to prepare to draw an arc. And I'm going to do this one in baby blue. So there we have an arc there. And then I'm going to make an arc on the other side just to don't have to move this compass more than once. Then we're going to place the compass on the other point. So we initially added a D prime. Now we're going to put it on D. And we're going to make an arc. And then we're going to swap it to the other side. And we're going to make an arc over here. And now we have the intersection of the arcs, which are of vital interest to us. And we're going to connect those intersections with a line segment. So, and that's pretty horrible. So I'm going to redo that with purple. Okay. And there. So we have a line going through those two intersections of the arcs that we made. And we have our perpendicular bisector. Okay, so now that we have that, and mine's a little off here, so I'm going to adjust it slightly. All right, so now that we have that, the intersection of these two bisectors is the center of rotation, right? So where this purple line and where this red line meet is the point that we're interested in. And I'm going to go ahead and I'm going to make a point there that's black. And I'm going to call that our center of rotation. I'm going to label it E, so that the center of rotation for these two shapes is point E. Okay, so now that we have that, we can start writing our rotation function. And for our rotation function, similar to the functions that are up here, it's going to start with R for rotation. And then it's going to have subscript E, because E was the label that we gave to our center of rotation. And now we need to find the rotation angle. Okay, and similar to how we were doing it up here, if we draw line segments to two corresponding points, we should be able to measure the angle between those segments and find the angle of rotation. So how does that look in practice? Well, let's draw two line segments, one to A and one to A prime here. And then let's measure them and see what we get. So we're going to draw a line segment from the center of rotation to A. And that line segment was rotated some degree to get A prime, right? So let's see what that line segment looks after it's been rotated. And if we did this properly, A should have traveled in a circular path to get over here to A prime. And we can measure that angle made by these segments in order to find the angle of rotation. Okay, so let's go ahead and position our protractor with the center at the center of rotation that we found, and with this line on our 0 degree line here. And we need to flip the numbers, obviously, so that actually is our 0 degree line. And then we can see that this has been rotated 40 degrees in this direction. And because that's in this direction, right, that's considered a counterclockwise rotation, which is a positive rotation. So 40 degrees in the positive direction. And so we go back to our rotation function over here and we write 40 degrees positive. Okay. And then all we need to put is our input, which are our original points or our original shape, which were A, B, C, D, and our output, which was our image points or shape, which is A prime, B prime, C prime, D prime. And right there we have the answer for 2A, which is the center of rotation, the angle of rotation, which is 40, and the rotation function. Now, one thing I want to note is that, again, this rotation angle that we found was between two corresponding points, right? A prime here, and this is just me wanting to point stuff out. Okay, so don't worry about this. It's not part of the assignment. I just want to point out something here, which is that when we found the center of rotation, we can place the compass there, and we should be able to draw the circular path that this point A traveled to get to A prime. Okay, so let's use black for this, right? Look at this circular path. That's the path that A traveled. And if A continued to rotate, it would follow a circular path all the way back to where it started. Okay, so that's what you have to keep in mind when we're doing this. Okay, is that these points, when they're rotating, they're following these circular paths. Okay, anyways, I just thought that was interesting to point out. Good luck with doing this for question B. Like I said, you just have to connect two corresponding points with a line segment, find the perpendicular bisector, do that for another set of corresponding points, find the perpendicular bisector, where they meet is the center of rotation. Then you use that center of rotation to find the angle of rotation between two corresponding points, and you can use that to write your rotation function. All right, so good luck with that.